Hey everyone, in today's video, we're going to be solving the problem search in a binary search tree. So the question says you're given the root of a binary search tree and an integer val. Find the node in the BST that the node's value val and equals val and return is the subtree rooted with that node. If such a node does not exist, return null. Okay, so what does the question say here? The question says that given a binary search tree, something like this, and what we need to do, let me just, let's see with the test case over here. So we have a binary search tree, something like this over here. Okay. Now, what we need to do over here is we're given a value val with us, and we need to return the subtree of that val. Let's say we have a val 2 over here. We need to check if 2 is present inside this tree or not. Here 2 is present. If 2 is present, then we need to return the complete subtree with 2. So we will return 2, 1 and 3 as our output. Understand? Now if we had a val of 7 over here, we would have just returned 7 as the output, because that is the only subtree that you'll get with 7. If you would given something like 4 over here, then your final output would have been something like the whole subtree would have been the output 42713. The complete thing would have been the output. Okay, so this is what the question is. Now, how are you going to solve this problem? Now, the traditional question of binary search tree is like you're given a value and you need to just check whether that value is present or not. If it is, then you just need to return a true or false. Right. Then for that, what we used to do is we used just loop through the whole tree, like, and we used to go to the left, then we used to go right, then we used to go to the left and right, then just used to check whether that value was present or not. And if it was present, we would just compare it and you check if it's present and we just return a true if it is. Right. But here you can't do that because you need to, because, firstly, it's a binary search tree. You don't need to do that. And second, um, because you don't need to do that, secondly, you have a less time complexity as well. Right, because in the previous way, you'll have a time complexity of O of n. Right now, you'll have a time complexity of log of n. And because it is binary search tree, you will get that. Firstly, let's say if we have you know, a value of 2, what would we do? So firstly, we'll check our question, we'll check our code with 4. Right. If 4 is present in the tree, right, 4 is, but 4 is not equal to 2, then we'll just check whether 4 is greater than the value or not. If 4 is greater than 2, right, we know that we need to go to the left of the tree because 2 is less than 4. If 2 is less than 4, then every value in a binary search tree is lesser in the right side, left side, and greater in the left side. So we need to go to the left of 4 to check whether 2 is present. And when we do find 2 over here, we'll just return, we'll check with 2 here. If 2 is present, then we'll just return true. We'll just return the whole subtree together with it. Right. So let me just do a dry run and show you how it's going to look like. So this is the code. What's happening over here is we have a root over here. What we're doing is, firstly, we're making a function recur over here because we're doing it recursively. We're going to check if root is equal to none or not. Right. Here, root is, not equal to none. We'll check if root dot val. Firstly, a root is 4, right? Now we're going to check if root is equal to none. It's not none. We'll check if root dot val is equal to val. If 4 is equal to 2, it's not. Then we'll check if root dot val, which is 4, is less than 2 or not. Right? We're checking here if 4 is less than 2 or not. So, no, it's not. Then what we'll do is we'll recur in root dot left. We'll go to the left hand side of the tree. When we go to the left hand side, we come over here and we check with 2. Right. When we check with 2, we see that if root is equal to none, it is not none. We'll check that if it is equal to val, which means 2 is 2 equal to 2, then yes. Within, if we do get a yes, we'll just return the root of the tree. When we return the root of the tree, we'll return the whole thing. This tree root with 2 with all its subchildren as well. Right. So this is how you're going to return the code. Right. So this is how you solve the problem, guys. And let's just run the code over here. Yeah, all the test cases are passing. And yeah, let's submit it. Yeah, it's getting submitted, guys. So yeah, guys, that's all for today's video. If you like the video, do like, share, and subscribe. Do let me in the comments what kind of videos you'd want next on the channel, do check out my podcast as well. And until next time, guys, thanks for watching.